Hi guys, that's going to be the second question on your homework of Atwood machines, and let's get started. So this time we're going to have an Atwood machine, but we're going to have two different strings attached. So you're going to have three different masses, not two like we solved in class. So that's 4 kg, and then you're going to have 2 kg right there, and then 1 kilogram right here. And basically that's the setup, and then once you release that system, the question is what will be the acceleration of 4 kilogram object. So like we discussed in class, this is going to be one of a question that we call system questions, because we have more than one object in the system. And for such questions, I use total force of the system equals mass of the system times acceleration of the system. Because for those systems, they're asking for acceleration of the 4 kilogram, but technically all of those guys, all of those masses are moving together. So all of the accelerations are equal to one another. So then once we find acceleration for the system, then it's going to be the acceleration for all of the objects. So now, then what we consider for system force is basically what makes all of those guys move, or what forces are actually affecting on that. And in this case, if you think about it, 4 kilogram object has some gravitational force acting on it, and this guy is pulled down by that gravitational force in this direction, and that is going to be basically 4 times 10, that is going to be 40 newtons down. So on the right side of the pulley, you have some 40 newtons of force pulling that system down. And then on the other side of the pulley, you're going to have 2 kilogram of object, and then gravity is acting on this guy. So that's going to be 20 newtons. Plus you have this extra 1 kilogram that is also creating, that also has some gravitational force acting on it, and that is 10 newtons. So on the right side I have 40 newtons of force, and on the left side I have 30 newtons of force. And these two guys are not helping each other, but they're trying to go against each other. So for example, if this guy was 30, then that system would be balanced, because they both are trying to pull it down. So they basically go against each other. So to be able to find the net force for my system, I have 40 newtons from the right, 30 newtons from the left, so I need to find the difference of those two forces to be able to find my net force on the system. So that is basically 40 newtons minus 30 newtons. And since that total force of 10 newtons, 40 minus 30, is trying to get this system move, I need to consider the total mass that is moving under that force. Then I need to add all of the forces, so 1 plus 2, which is 3, 3 plus 4 is 7. So 7 times acceleration of the system. Then that is going to be equal to 10 equals 7 times acceleration of the system. And that acceleration will be equal to 1.43 meters per second squared. This is going to be the answer for part A. In part B, they're asking for the tension on the string that is attached to 4 kilogram object. So they're basically asking for this tension in second part. And since they're asking for tension, we can go individual forces, individual masses. So what's the free body diagram of that 4 kilogram object? Well, by the way, this is going to be the magnitude, and let's see, They are not asking for the magnitude of the acceleration, they are actually asking for the acceleration. And since this guy is heavier on the right side, this guy is going to accelerate downward. So this acceleration is supposed to be negative 1.43 meters per second squared. And that's important. If they were asking for only magnitude, that positive negative would not matter. But since they are only asking for acceleration, you need to specify that it is negative. Alright, for part B, they are asking for tension. So free body diagram, all we need to do is draw the free body diagram of 4 kilogram object, and you have Fg acting on that 4 kilogram object, which is 40 newtons. And then you have F tension that we do not know. So F tension goes up. But luckily these two are the only forces acting on the object. Then if you would like to write down Newton's second law equation, net force acting on that object must be equal to mass of the object times acceleration of the object. And net force, Ft goes up, so that's positive. Mg goes down, which is 40, and that's going to be negative 40 since it's going down. Mass of this block is 4 kg times acceleration. And we found acceleration, and that is going to be negative. Again, that's important. That is negative 1.43. So all we do is substitute the numbers that we found in the other part of the question. And now, what is my F tension going to be? F tension minus 40. 40 is going to go to the other side. So 4 times 1.43 is going to be equal to 5.71. So 5.71 plus 40. So your F tension will be equal to, sorry, that is going to be negative. So your F tension will be equal to 34.3 if you would like to round it correctly. So tension on that string is going to be 34.3 newtons. In part C, they're asking for the tension on the string that is attached to that 1 kilogram object. So again, this time they're asking for this tension. So the way that we can find that will be very similar to this guy. Actually, it's going to be the exact same thing for this as this guy, because to be able to find that tension, you just need a mass that is attached to that string. So if you would like to find that tension, you could have used that 2 kilograms object as well, but that has this tension plus this tension and mg. So that's going to be a little bit more complicated. So that's why it's not like a good idea to choose 2 kilogram object, but you can technically find it. Again, for the tension on the string, same thing. You can either choose 2 kilogram object because this string is attached to 2 kilogram object. So that tension will be on that 2 kilogram object's free body diagram. So technically you can find it. But again, you have tension, gravity, another tension. So you're going to have 3 different forces, and that is going to take a longer time to find. So it's going to be a better idea to choose this 1 kilogram object because you only have 2 forces. Tension goes up, gravitational force goes down. So again, let's draw the free body diagram for this 1 kilogram object, mg, which is 10 newtons, and then you only have the tension that we are looking for on that object. So Ft goes up mg, which is 10 Newton, goes down, and basically that's what they are asking for, the tension. Again, what are we going to do? Same equation. Force equals mass times acceleration. So force goes up is tension, and force goes down is -10. And my mass, I'm talking about this 1 kilogram object right now, so that's going to be mass of that object, which is 1 kilogram, and acceleration. So we calculated the acceleration, and that is going to be the acceleration for the system, which means this 1 kilogram object is also accelerating with 1.43 meters per second squared. But this guy is accelerating upwards, so that is going to be positive 1.43 meters per second squared. Then your F tension will become 10 plus 1.43, so your tension then will be 11.43 newtons in total.